Have you ever stared at your TV or phone screen and wondered how it creates a perfect, sunny yellow or a deep royal purple? Think about the last movie you watched or the video game you played. You saw lush green forests, bright blue skies, and fiery orange explosions. The world on your screen looks just as colorful as the real world, with a seemingly infinite palette of shades and tones. But the device creating this incredible rainbow is surprisingly simple. It's working with a very limited set of tools. This presents a huge challenge for engineers. How do you paint a masterpiece with an endless number of colors when you only have a few crayons in your box? The secret isn't magic. It's a brilliant combination of science and a little bit of trickery played on your own eyes. If you could zoom in on your screen way past what your eyes can normally see, you'd find that the picture is made of a grid of tiny dots. This grid is like a massive piece of graph paper, with millions of squares filling the screen from edge to edge. A single pixel is the smallest possible dot of light that your screen can control. By itself, it doesn't look like much. But when millions of them work together, they form the sharp, clear images that we see every day. Now let's zoom in even further on just one of those millions of pixels. This is where the real magic happens. You would discover that a single pixel isn't just one light. It's actually made of three even smaller lights nestled right next to each other. And these three lights are always the same three colors: one red, one green, and one blue. That's it. That's the entire toolkit. Every single color your screen has ever shown you was created by mixing just red, green, and blue light. This is known as the RGB color model for red, green, and blue. It's the foundation of every digital display you've ever looked at. But how do three colors become millions? This works because of a principle called additive color mixing. If you shine just the red light on a white wall, you see red. If you shine just the green light, you see green. But if you shine the red and green lights on the same spot, something amazing happens. Your brain doesn't see red and green. It sees yellow. Your screen is doing the exact same thing. When the red and green subpixels in a pixel light up together, your eye sees that pixel as yellow. The same thing happens with other combinations. If you mix green and blue light, you get a beautiful bright cyan. And if you mix blue and red light, you get a vibrant magenta. We've just created three brand new colors: yellow, cyan, and magenta, without having any lights of that color. So what happens if you turn all three lights on at full power? Red, green, and blue light mixed together in equal amounts creates pure white light. And if you want to create black, that's the easiest one of all. The screen just tells the red, green, and blue subpixels in that spot to turn off completely. The final piece of the puzzle is intensity. The screen's computer can tell each subpixel not just whether to be on or off, but exactly how bright it should be. Think of each red, green, and blue subpixel as having a dimmer switch, like the lights in a dining room. This dimmer switch is incredibly precise. Each subpixel usually has 256 different levels of brightness, from 0, completely off, to 255, full power. Now the possibilities explode. Let's go back to our yellow, which was made of full power red and full power green. What if we use full power red, but only half power green? We don't get a bright yellow anymore. We get a deep, rich orange. What if we want to make brown? Your screen might use a strong dose of red, a medium amount of green, and just a tiny bit of blue. To make a soft lavender, it would use a lot of blue, a little less red, and almost no green. Every single one of the millions of colors you can see has its own unique recipe, a specific brightness level for red, green, and blue. The math is 256 times 256 times 256. That gives us over 16.7 million different color recipes that each tiny pixel can create. This is why modern screens are capable of displaying what is called true color. They can generate more distinct shades than the human eye can even differentiate. But there's one more crucial element to this whole process: you. More specifically, your eyes and your brain. The subpixels are so tiny and packed so closely together that from a normal viewing distance, you can't distinguish them individually. Your eyes don't see the separate red, green, and blue dots. Instead, they automatically blend the light coming from them into a single, solid color. The screen isn't really making yellow. It's showing your eyes red and green light so close together that your brain does the work of mixing them into yellow. It's a clever illusion, repeated millions of times across the entire display. Each pixel is like a tiny pointillist painter using dots of pure color to create a blended masterpiece. For a high-definition screen, that means a computer has to calculate the correct red, green, and blue values for millions of pixels, and it has to do that calculation dozens of times per second. It's a massive amount of data, all crunched in real time, just so you can watch a cat video or explore a new world in a game. So the next time you look at a screen, remember the hidden complexity behind that simple, colorful image. The big insight is that immense, beautiful complexity can be built from very simple rules. The entire visual universe of the digital world, every photo, every movie, every app, every website, is not painted with a million crayons. It is built from the ground up using just 3 tiny lights, repeated over and over again. Red, green, and blue. This idea of creating complex systems from simple components is a cornerstone of science, engineering, and coding. It's how we build everything from a skyscraper to a software program. The solution that engineers devised for creating digital color is both incredibly efficient and brilliantly simple. Instead of trying to create a light for every color, they offloaded the work to our own brains. You can even try to see this for yourself. If you have a magnifying glass, hold it up to a white part of your screen. You might be able to spot the individual red, green, and blue dots firing at once. The vibrant, endless world on your screen is just a beautiful illusion painted for you with only 3 colors of light